This is a continuation of solving exponential equations part 1, and this lesson will show you several examples that will help you expand your knowledge of how to solve exponential equations. So in this example, we are given 27 is equal to 3 raised to the 5x plus 9 raised to the x squared. And so I'm thinking about, well, what do I have before me? And of course, my first tactical move is going to look for bases that can be written the same. And so I'm familiar with 27, 3, and 9. And of course, I can write all those terms in terms of base 3. And so 27 in terms of base 3 is going to be 3 raised to the third power. We already have 3 raised to the 5x. That's already in base 3 or has a base of 3. And then also our 9 can be written as 3 squared. So that's in terms of base 3 as well, or has a base of 3. And so now I'm kind of there, I'm getting there, but I still can deal with simplifying that power to a power of a power. So I'm going to go ahead and multiply that 2 times the x squared, because those are the laws of exponents that say I need to multiply there. So I go ahead and multiply, and now I'm looking at all bases 3, and their powers are different. So I'm just going to represent their powers for what they are, even though those bases are 3, because those bases are 3. So now I bring all of those out of the sky, which is, remember, that's what we're trying to do here. That's the challenge here. We use logs when we can. We use changing the base of getting like bases when we can. And so in this case, got the like bases so I can pull those powers out of the sky. Now I just have a simple equation that I need to solve. And so at this point, your challenge is to recognize that what kind of equation you have that you need to solve. I recognize that this is a quadratic equation. And remember, quadratic equations can be solved in various ways. They can be solved using the square root property. They can be solved using factoring. But the only certain ways that can solve every single quadratic equation would be either completing the square or using the quadratic formula. So remember, those are the 2 primary methods by which you can solve a quadratic equation. So let's work on that. So if we look at the completing the square option, remember, you get to choose which option is your favorite. But looking at completing the square option, we'll want to first get rid of that coefficient of x squared, because we can actually employ the completing the square method with that coefficient. It's not a perfect square, and we need to get rid of it. So I'm going to divide the entire equation by 2, and so that's all that's happened up to this point. I've just divided the entire equation by 2. And so now, also with completing the square, I need to deal with that 5x over 2, because that's my jewel. And so I'm going to get the negative 3/2 out of the way. I'll move it to the other side, and now I can create a perfect square trinomial on the right by taking 5/2. I can cut it in half, okay? I can take 5/2, cut it in half, and square it. Okay, that's the kicker with completing a square. Take 5/2, cut it in half, and square it. So do that by hand in your calculator, however you deal with it, but you'll get 25/16 when you do that. And you can add 25/16 to both sides of the equation without affecting your equation, really, because you're just adding the same thing to both sides. What you're doing on one side, you're doing to the other, so no problem. So we add 25/16 to both sides, which has brilliantly created a perfect square trinomial on the right, which can be written as a binomial squared. So now I have x plus 5/4 quantity squared on the right. Doesn't matter too much what I get on the left, but it just so happened what I got on the left anyway was a perfect square. I'll take the square root of both sides. That's the beauty of completing the square. It gives us the opportunity to take the square root of both sides, thereby using the square root property to give us what we're looking for. And so kind of look at that 49/16 as a square root of 49 and a square root of 16. And so once we do that, we need to look at both sides of this thing. Because remember, we have the positive side of a square root and the negative side of a square root, because you don't know if you squared a number. For example, if you squared or if you took the square root of 9, did you start with a negative 3 times a negative 3 to get the 9? Or did you start with a positive 3 times a positive 3 to get the 9? So for that reason, we look at both sides of the event, possible event, in terms of taking the square root. So on the left of this red bar here, I have a positive 7/4 that has come out, and then I have a positive x plus 5/4, okay? And so I deal with that and I draw it out to a conclusion by solving for x. And when I do that, I end up with x is 1/2, or 1/2 is x. Okay, so I have a solution to one of the solutions to my equation. Now on the other side of this square root, I still have to deal with that 49/16 because that we don't know. Was that square root of 49? Was that negative 7 times negative 7 or positive 7 times positive 7? So now I'm looking at the negative side of it. So I have a negative 7 in that numerator. Same thing with the 16. Was it a positive 16? Was it a positive 4 times positive 4 or negative 4 times negative 4? So now I'm looking at the negative 4 possibility. And also I'm looking at the negative x plus 5/4. Okay, I'm looking at the negative side of that. So I have to simplify here. So I do perform some simplifications. I really end up with 7/4 on the left, negative x minus 5/4 on the right, and then I add 5/4 to both sides, and then I end up with 12/4 on the left, negative x on the right, and of course I can simplify that 12/4 to 3, and then of course that divide the whole thing by -1, and I end up with -3. So I've abbreviated a little bit here, but in conclusion, I'll end up with x is -3 and x is 1/2. And so then we continue and take a look at the quadratic formula side, because we could have solved this equation by way of the quadratic formula. So if you had chosen to use the quadratic formula instead, you would apply the quadratic formula. The terms of this quadratic formula were a means a would be equal to 2, b would be equal to 5, and c would be equal to -3. Well, then the formula there will be filled in as such. So be very careful with your signs. So easy to mess them up. Once you're orderly and organized here, then you can just continue to unfold this thing and see where we leave off. And remember, x is equal to, or the value of x in our equation is plus or minus that discriminant. And so we look at both sides of it, plus the discriminant minus the discriminant, and then we unfold both ends, and we discover that x is either 1/2 and x is -3. And of course we'll test those in light of our original equation. So if we go back to our original equation, we're now saying x is 1/2 and -3. Those are the two numbers that can make a true statement. So we look at both situations. We look at what happens if x is 1/2. And so we substitute that into the very original equation. We unfold you can use your calculator for this or do this by hand, but you discover that 27 is 27. And so that's, of course, a true statement. And then the same thing if we try our -3 as the value of x in our original equation. We substitute and we simplify, and we discover also that 27 is 27, which is a true statement, which means these are indeed solutions for our original equation of 27 is equal to 3 raised to the 5x plus 9 raised to the x squared. In this example, we're given 3 raised to the x is equal to 2 raised to the x minus 1. Now again, we cannot write like bases, so we'll rely on the properties of logarithms. I'll take the log of both sides. No problem, as long as I'm not altering this equation, as long as I keep it in balance and do the same thing to both sides. So I'm going to take the log of 3 raised to the x and the log of 2 raised to the x. What does that do for me? That pulls those values out of the exponent. So now they're down out of the exponent. I can work with them a little more. But then again, I may look here and see I have x times the log of 3 equals quantity x minus 1 times the log of 2. Just like in equations of the past, when it's time to distribute, we need to go ahead and distribute so that we can see actually what we have and deal with it. So I've gone ahead and distributed on the right side log of 2 throughout that parentheses. So now I have x times the log of 2 minus log of 2. All I've done was distribute. Multiply that log of 2 times the x and multiply that log of 2 times the negative 1. Now I can manipulate here. Remember, those logs they are constant values, so they behave like constants. So we can deal with them just as if they were just numbers with which we're familiar. So I'm looking to get the variables together. Those x terms need to get together. So I'm going to rearrange this equation and get those x terms together. See, this is all about just seeing what we have for what it is. So those x terms need to get together, and now I have x times a log of 3 minus x times a log of 2 because I've moved that term, x times a log of 2, to the left. Why did I move it to the left side of the equation? Because I need the x terms to be together. Now I'm just left with negative log of 2 on the right side. I'm always respectful of my signs. And now I can factor out the variable x on the left, leaving me with just a constant inside that parentheses on the left and a constant on the right. Remember, the log of whatever number is a constant value. Now I can, these again behave like constants that we always, or coefficients that we've used in the past. So I'm going to divide both sides by that coefficient, if you will, of x. And so both sides of the equation get divided by log 3 minus log 2. Once I do that, I'm left with x is approximately, because again I have rounded this value, so I have x is approximately 1.7095. Okay, let's take a look at this special example. Here we have e to the x minus 6e to the negative x is equal to 1. So our task is to determine what is the value of x. Okay, so keeping that in mind all the time, we're just looking for what is the value for x, and we're going to use the properties and rules for solving equations that we have available to us. So the first move I'm going to make is to get rid of that negative power of x in order to sort of start to at least isolate e to the x. And so this happens very often. If we have that negative power, we want to move or shift that term or that piece to either the numerator or the denominator, depending on where it is. And so it's in the numerator, we want to drop it to the denominator. It gives us e to the positive x. Again, laws of exponents. So the next thing I want to do is get rid of the fraction. Hey, why not? So I can multiply this entire equation by e to the x. So notice what happens if I multiply the first term. There are 3 terms inside of that parentheses. Notice I have e to the x, that's my first term. My second term is negative 6 over e to the x. And my third term is 1. Okay, so let's go ahead and multiply. So I multiply that first term times e to the x, and of course e to the x times e to the x is e to the x squared, okay? Or e to the 2x is how we write it. So we have 2 of them. So we have e to the 2x, okay? So it's a little tricky and it's something to get used to, but if we multiply e to the x times e to the x, we have 2 of those x's in the exponent. Okay, and then what happens when we multiply negative 6 times, we multiply e to the x times negative 6 over e to the x. And so, of course, that e to the x cancels with that denominator of e to the x. So we're just left with negative 6. And then what happens when we multiply the value of 1 by e to the x? Of course, we just have e to the x. So now we can rearrange our equation because it's feeling like a quadratic. We've got a power of a value squared. One of our terms is squared. We've got 1 to the first power, and we have a constant. That's looking familiar, so I've rewritten it, put it in descending order, our square term, our first power, and then our 0 power, or our constant. And then, of course, on the right-hand side of the equal sign, I didn't leave anything over there, so just indicate there's a 0. So here's a trick. We revert back to what we know about quadratics. And I'm going to, if I recall correctly, it's this course by which we learned to write an equation or rewrite it in terms of a quadratic, or reduce an equation to a quadratic. So here's an example of reducing an equation to a quadratic. It's not exactly a quadratic, but it behaves like one. So let's rewrite it in terms of a quadratic. If everywhere we have e to the 2x, we just use x squared. And everywhere we have e to the x, we just use x. Well, then we can solve the equation that you see inside of this box here with painlessly. And so I'm going to solve that equation just by factoring. So we factor this x squared minus x minus 6 equals 0 into x plus 2, that quantity, times x minus 3. And that is equal to 0. And of course, these are very simple for us to solve. We have two possible solutions. Again, I emphasize possible solutions. X plus 2 is equal to 0. X minus 3 is equal to 0. If we solve x plus 2 is equal to 0, we'll get x is equal to negative 2. If we solve x minus 3 equals to 0, we'll get x is equal to 3. Okay, so we can take this information and insert it back into our e to the x equation, because again, how does this e to the 2x minus e to the x minus 6 equals 0 behave? Well, exactly like x squared minus x minus 6. And so it will yield the same value or come back to the same value. But we have to keep in mind that x equals negative 2 won't do for us, because we can never raise values of e to the, or we can never raise e to the negative power. And so for that reason, anytime you have solutions that suppose e has been raised to a negative power, you have to discard those solutions. And you can play around with that in your calculator, and you'll see that you'll get an error message when you try to raise e to the negative power, which is a whole lesson in itself. But even so, when that happens, I want you to discard that. We'll call them extraneous solutions. And so you'll discard that extraneous solution, and we'll just stick with x is 3. So if x is 3, that means x is 3 in the quadratic, the way that quadratic behaves. But in terms of our e equation, e to the x is actually 3. Because remember, we replaced our x's with e to the x. So it's actually e to the x that is equal to 3. Okay, so now we're almost there, but we need to get that x out of the sky. So let's do that by multiplying both sides of the equation by the natural log. And so now we have the natural log of e to the x equals a natural log of 3. And then we can pull that x out of the sky. Remember that the natural log of e has a value of 1. So we really have x is equal to the natural log of 3. Okay, which you can do that in your calculator, and you'll get a very long number, and you can round it. I've rounded here to 1.0986.